And welcome to Mission Control Houston. We're going to send the signal out to Marshall Space Flight Center in Huntsville, Alabama at the Payload Operations Integration Center. So that Lori Meggs is standing by there to tell us more about the research on the space station. Hi, Lori.
Hi, Kelly. Well, learning about the human body and how it functions in microgravity is paramount to future spaceflight. Astronauts are asked to participate in studies for the Human Research Program, and one of those studies going on right now is called the Functional Task Test. And I recently spoke with the principal investigator of that to find out a little bit more about what they're doing.
We're involved in an ISS study called the Functional Task Test. And the Functional Task Test is really looking at how multiple physiological systems impact ability of astronauts to do functional tasks. Over the years, we've done a really good job at defining how individual physiological systems change as a result of spaceflight, but we've never put the pieces together in one complete study. But more importantly, we've never linked those physiological changes to functional changes in astronauts, really operational changes. So the Functional Task Test is really an integrative study involving three of the labs at JSC, the Cardiovascular Lab, the Neuroscience Lab, and the Exercise Physiology Lab, are focused specifically on making that link between functional changes and the underlying physiology involved. And ultimately the reason for doing that is we're interested in developing countermeasures, and we want to focus on the countermeasures on systems that really make a difference in terms of functional change.
Have you seen over the years a lot of functional change, the things that change in microgravity?
Sure. I mean, some of the more obvious changes we see are in postural stability and ability to walk. We've done previous studies where crew members walked obstacle courses and did those type of functional tasks. We see significant postural instability after spaceflight. That's my sort of area of interest. But of course, you see changes in other physiological systems too, like the cardiovascular system. There's orthostatic intolerance, which is the potential for fainting when the crew member stands up. There's muscle performance changes, there's strength changes, there's muscle atrophy. So all those systems sort of combine together to create the change in functional outcome.
So how are we studying this? How is it operationally for you?
This is a pre and post-flight study, and we test them 3 times pre-flight, and then we're able to test them 24 hours after landing. The crew comes from ISS, lands in Russia. They fly back to Johnson Space Center, and we start doing the data collection there about 24 hours after landing. And then we test them 6 days and 30 days. Now, the way we test them is we have a set of functional tests that we do, which are things like obstacle course testing, hatch opening, ladder climbing, various tasks of object displacement, so various hands-on functional tasks. And then we have a set of corresponding physiological tasks that look at various physiological changes that include changes in muscle performance, neurological changes, and cardiovascular changes. And putting all those pieces together is really what we're trying to do.
I'm going to tell you, I'd hate to be on space station and then come back and have to run an obstacle course. That would not be fun.
Yes, it is challenging, absolutely.
Tell me how long this has been going on and how long it will go on.
Well, we've already completed 7 subjects. We're asking for 13 subjects, so we're about halfway through our subject count. We've been doing the experiment for about 2.5 years, and we expect another 2 years to collect the rest of our data.
Have you learned anything so far that you can share?
Some of the preliminary data, when we look at some of the functional tasks, show that clearly the functional tasks that require postural stability are affected the most. So our obstacle course tests, our postural stability tests, those are the tests. Tests that have less requirement for postural stability, like hatch opening, where you can hold on to the hatch, those tests seem to are less impaired by spaceflight.
And along the lines of human research, we want to share some news about a recently identified health problem with astronauts' vision and some new research that is leading to. It's called the visual impairment and intracranial pressure risk, and it has become the #1 human spaceflight risk. When we talk about intracranial pressure, we're talking about pressure inside the brain. And on orbit, crew members experience fluid shifts to the head caused by microgravity, and therefore it's hypothesized that all crew members have elevated intracranial pressure to some degree. Researchers have linked this increased pressure to changes in vision in long-duration astronauts. Now, when the vision impairment study began, all crew members pre-flight had normal eye examinations, but post-flight measurements showed a degradation in vision, primarily increasing farsightedness. 41 crew members have flown to date, and of those, 19 were identified as having visual changes on their return. 6 did not have symptoms, and 16 others could not be classified as they flew in the early increments, which did not have the imaging techniques available as in the last 6 to 7 years. Now researchers are looking at finding a technique to measure these visual changes in flight non-invasively and to understand what's contributing to it. A technique like this is highly sought after on Earth, as well as to measure intracranial pressure, and NASA is on the cutting edge of that research and identifying devices that could be used in flight. Results of these studies may also be relevant for patients suffering from eye diseases here on Earth, such as glaucoma. NASA's Human Research Program will look at this risk over the next 10 years and find investigators to study the intracranial pressure syndrome, which will include clinical and research studies on orbit.